So, you're looking at stress raisers. Stress raisers in civil structures might not be a crack. It might be a 90-degree bend in a concrete structure. That 90-degree bend, the stress builds up and initiates cracking there. It might be in a weld. Let's go a poor quality weld, where they've actually heated it up too much. There's the weld, that's called an undercut. That's a stress raiser. You might have actually not fully welded through and left a base in a steel structure where there's a gap and a stress raiser. Key point you need to know is stress raisers raise the stress to a point where it's above yield. The rounder, the more blunt the tip, the less the effect of the stress raiser. What they do in industry, what we used to do in the steel works, was we'd have 400 tonnes of molten steel hanging off a ladle. And last thing you want is one of the two lugs falling off the ladle. Not with 400 tonnes of steel. I have seen 400 tonne of steel molten, solidified on the ground. It puts a furnace out of action for about 3 weeks while you cut it out. So, because just imagine 400 tonne block of steel. Divide it by 8 tonnes a cubic metre, that's 50 cubic metres of steel. Sitting in a lump. About 4 metres thick, yeah? So, how do you get rid of it? Stress raisers. If you do your cracks, we spoke about crack testing. You've seen a dye penetrant test used for, I've got the word here, fatigue cracking. If I've got a crack that you detect, the dye penetrant shows it up to here, Jen. Guys, yeah. The dye penetrant shows it up to about this point. Microscopically, that yielding has already happened out to there, but you cannot see it yet under a dye penetrant kit. So you get a drill bit and you drill a round hole out there. The crack grows into that hole, and now there is not a sharp stress raiser anymore. That hole is a crack tip blunter. Reduces the stress. It's not a fix, but it's a stand-in for about a week or two until you can get to fix it.